Hey gang, I'm going to go through this little whiteboard review just to make sure you're all good with these various problems. These are the learning targets for this particular module. Alright, this one I probably don't have to go through, so you can see all the work there, solving for x. And this one, you can see, I'll probably just solve this one. So we distribute the 3, so we get negative 6x minus 12 equals negative 24. And then we add 12, This will be negative 6 is equal to what? Negative 12 divided by negative 6, and you get a positive 2. Alright, and then we got this one, so this one's probably easy for y'all as well, so I won't spend the time going through every single one. Well, let me go back to that one for a second. So this one, the work is that we add 3. Oops, let me go back, sorry. So we add 3 first, 3x to both sides, and that'll cancel this out, so then this will be 10x. And then what we do is we're adding 1 to the other side. So when we have negative 19 plus 1, that's where we get that negative 18. And then we divide by 10 on both sides, so negative 18 over 10. Or we could reduce that negative 9/5, or what a lot of people were saying today is negative 1.8. So that would be great as well. Negative 1 4/5. All of those are good answers. And solving for x. So here, solving for x, we're going to distribute the 2, you can see. And so we get 10x plus 14. Then what we would do is we would like to add the 4x. So we add 4x. That's where we get that 14x. And then we have to subtract 14 from each side. So we get negative 9. And then we divide by 14. So negative 9 over 14 is a great answer. All right, we want to sketch the graph. So the vertex is negative 4, 2. So we just go over to negative 4. We go up to 2. There's the vertex. And the zeros are wherever it crosses the x-axis. So it crosses at negative 2 and then at negative 6. And so we know the only way to sketch the graph would be opening downward. All right, this one is... Oh, we got an email in. Okay. So this one, the vertex is 3, negative 2. So then we just plot the vertex. 3, negative 2, which would be right there. And since it has no real zeros, that means it doesn't cross the x-axis anywhere. So it has to open downward. We don't really know how wide it opens up or anything, but it definitely opens up downward, or opens downward. All right. All right, so now this one has all the features. So we just look at it and say, okay, we've got the vertex there. So that's our 216. Looks like it's hitting right, 216. The axis of symmetry, of course, is that line that cuts it right down the middle. So that's x equals 2. The zeros are wherever it crosses the x-axis. So that's going to be x equals negative 2, and then x equals 6. As x approaches infinity, meaning as we're moving this way, what's happening to the y values? Well, the y values are getting smaller, they're going down, and so they're approaching negative infinity. And then as x approaches negative infinity, that means x is going this way. What's happening to the y values? Well, as I move to the left, in the x direction to the left, the y values are also getting smaller, so that's negative infinity. Remember that these two answers will always be the same, whether they're negative infinity or whether they're both positive infinity. So when the graphs are going down, we can always say it's going to be negative infinity, and if the graph is going up, then we would say positive infinity for both of those for end behavior. The increasing interval, that's going to be when the graph is going up. And you might say, oh, I don't really know if the graph is going up. Well, when you look at the graph from left to right, the graph is going up. It's rising during that interval. So that's from negative infinity all the way to right where that vertex is, the x-coordinate of that. So that's 2. Then it is decreasing during this whole interval. So once it hits 2, then it starts going down. So it's decreasing. So it's going to be from 2 to positive infinity. Okay, next one, pretty similar. The vertex is going to be right there at 0, 0. The axis of symmetry is x equals 0, cuts that parabola right in half. The zeros are wherever the x-intercepts are. It has one x-intercept, so it's x equals 0. The end behavior as x approaches infinity, the y is approaching infinity as well. It's getting bigger. As we're moving this direction, the y's are getting bigger. If we're moving this way, as x approaches negative infinity, the y values are also getting bigger. So again, these are the same, okay? The increasing interval, that's whenever the graph is actually going up, and you can tell it's going up the whole time from 0 to infinity. And then it's decreasing this whole time, so that's from negative infinity all the way to right there, right at 0. So we would say from negative infinity all the way to 0. Didn't want to erase that so it doesn't look like it's a negative sign or anything. All right, so next one, this is describing kind of what's happening to the graph. What are the transformations? Well, this right here, the +6, when it's inside the parentheses, that's affecting the x's. So this is going to be 6 units to the left. So you can say it's transformed, it's shifted, 6 units to the left. I'm just going to say, for right now, I'm just going to say 6 units left, just abbreviating a little bit. And then what this does is it does a couple things. So, oops, I don't want that to look like it's a -6 or anything. I'll just do bullet points. The minus sign is going to reflect it over the x-axis. So I'm going to say reflected over x-axis. And then what the 0.5 part does is, because it's a number that's smaller than 1, it vertically compresses the graph. So vertically compressed. And it's vertically compressed by a factor of 0.5, okay? So by a factor of 0.5. All right. Then this one, let's see, this is 10 units. It's inside the parentheses, so it's going to be 10 units to the right. So 10 units right. And then this one is outside of the parentheses, so that's going to be 15 units, and that's down. Okay, this one is filling in the table correctly when we compared this graph with the mommy graph. So this only has a change in the x's because it's inside the parentheses. So this is x minus 3. This is the one that's counterintuitive. We see the x minus, we're like, oh, it's got to be, moving to the left. No, it's moving to the right 3 units. So if it is moving to the right 3 units, then we add 3. So -2 plus 3, that's going to be a 1 there for the new x-coordinate. -1 plus 3, that's going to be 2. 0 plus 3, that's going to be 3. 1 plus 3, that's going to be 4. 2 plus 3, that's going to be 5. Now there's nothing here that affects the y-coordinates, so the y-coordinates would stay exactly the same. Then you can plot it. So when you plot those points, it should be a graph exactly transformed to the right 3 units. So it has a new vertex, you can see, it has a new vertex right at 3, 0. And then the rest of the points, you just, plot them like normal. So it kind of looks like this. And then 4, 1 should be right there. 5, 4, about right there. And there you go. And you can fast forward, pause for any of this, right? That's what's nice about a video. All right, so this one, it doesn't have anything inside the parentheses, so there's no change to the x's. So we could go ahead and just rewrite these. Now the y-coordinate is going to be affected. It has a minus sign there, it has a plus there. You got to do this in a particular order. You always got to take the current y-coordinate and multiply it by whatever on the outside here. That happens to be a -1. So we multiply this by -1. So 4 times -1, that's -4 plus the 3, so that's -1. We take the 1, we multiply it by -1, that's -1 plus 3, so we get a 2. 0 times a -1, that's still 0 plus the 3, so that's 3. 1 times a -1, that's -1 plus 3, that's 2. 4 times -1, that's -4 plus 3, so that's -1. Look at the symmetry that's here, so that's got to be the case, okay? So then we just plot our points. So we got -2, -1, just real roughly, -1, -2, 0, JK, screwed up these points. Okay, let's plot these points again. So -2, -1 right there. -1, 2, which would be right there, and then 0, 3 right there, and then 1, 2 right there, and 2, -1. Okay, and then we can just connect the points, and you look at the graph and you go, wow, okay, that is reflected over the x-axis, and then it's added 3 units to it, so the graph is shifted up 3 units. So everything should make sense. The words, the table, the graph, it all is in perfect alignment. All right, now we're solving these. So if you're solving, I'm gonna try to fit them all on here, you know. So I don't know if I'll solve all these or if I'll just, maybe I'll just solve a couple of them. Okay, so -3x squared equals 192, if it lets me. Come on, you little booger. Okay, so then we're going to divide by -3, and when you divide by -3, you get -64, and then you want to take the square root, so you get x equals, and we always have to remember to do the plus and the minus for all of these. So then when we take the square root, we know it's a perfect square, but it has this little negative under there, so that's where we need to have the I. That's how we deal with taking the square root of a negative. Okay, so similar here, we come over 4x squared, we add the 96, x squared equals, we got to divide by 4, so let's see, that is 24. Then we'll take the square root of both sides, so that's x equals plus and minus square root of 24. Now then we want to break this down, and we can say, hey, that's really, like the square root of 4 times the square root of 6. So that's plus and minus, that'll be 2 square root of 6. If I was solving this one, I probably would just add the x squared over to the other side. Then I would take the square root of both sides, so that would be x equals plus and minus the square root of 75. The square root of 75 can be broken down, so it is 25 times 3, and that means I could actually take the square root of 25, so my best answer is plus and minus 5 square root of 3. That's what x is. Next one, we would add 18, and then to get rid of the 1/2, it's a good idea if you just multiply by 2, so that'll cancel out. That'll give us x squared equals 36, and then we can just take the square root, so x equals plus and minus positive 6. No imaginary unit needed there. And then really the last couple problems, they're just using the calculator. So just try to put that link on, or I did put the link of MathBits on the computer. So you'll just have to look at that. But what you're doing there is you're just replacing the 0 with a with a y, graphing it, seeing how it looks. Yeah, so you probably just have to kind of see me on this one. I try to put some screenshots as well on here, but those are the answers that you get when you use the calculator. This is what I got when I was doing it. I got one of the zeros turned out to be the negative 6.54, which is right there. And the other one right there is negative 0.46 when you round it. Hopefully you've asked me about that if you're not sure. And then the next one, when I graphed it, I got, it looked like, this graph. So I found one of the zeros was right here, and it was 0.25. And then the other one was right there, and it crossed the x-axis at 2. So those are the two answers. That satisfies the quadratic equation. So each of those numbers makes that equation true. All right? So hopefully that helps a little bit. Good luck.